I'm Tymek. I'm a junior embedded systems developer at FrameDev, and today I'm going to talk about fido-device onboarding and how we manage to and its implications in implementations in Yocto. Sorry, and yeah, I switched slides to early. So yeah, that's me. As I said, I'm a junior developer, so please bear that in mind. This is my first conference talk, and yeah. So what is FrameDev? We specialize in open source firmware development and embedded systems, and I've had the pleasure of integrating FDO into one of our products for client. So what is FDO? Oh yeah, agenda. Sorry, my software is a little bugged and I don't have the notes available as easily as I do want to. So yeah, we'll talk about what is FDO, what are the current implementations of FDO protocol, and how the challenges behind integrating one of them into Yocto environment. And we'll end everything with a technical demo. So FDO was originally developed by Intel and under the name SDO, Secure Device on Board, and it focused on providing safe and scalable zero-touch device deployment for IoT and embedded systems. And later was open sourced with the help of the FIDO Alliance, which you might know from the Fast Identity Online protocol and technical specification, and renamed to Fast Identity FIDO Device Onboard-rs, which is an acronym for Fast Identity Online Device Onboarding. And yeah, it's an open standard and aims to set a new benchmark for IoT devices onboarding. Yeah, and this is a quote from their specification. So yeah. Okay, so let's explain how FDO works. Let's start small before it gets too confusing. So yeah, the basic gist is that a manufacturer issues a device with a certificate. It goes through every stakeholder in the supply chain, and the end client can verify if every stakeholder signs the certificate with their private key. And the end client can verify if the device has traveled the full chain. And if the trust is established, then it can provision. There are also other implications with this. So, for example, the end client can, there can be an, oh, sorry, I forgot the phrase for it, but the file system can be locked down until the provisioning. So the device can achieve full security. So yeah, this is the expanded graph, how it all works. So as you can see, the ownership voucher travels independently from the device. And that's the part that is actually signed by every stakeholder. And they're tested if they align. It's so yeah. FDO uses three main protocols to achieve this. This is, again, expanding on the previous slide. So there is TO0, TO1, and TO2 protocol. So besides IoT device, there are two instances servers that are present in the onboarding process. So one is a rendezvous server and one is the actual onboarding server. And as you can see from this graph, the rendezvous server holds the information about the ID of the device. And when the device is plugged in, for example, plugged into the internet and booted, then it tries to connect to the rendezvous server. Because it also has its information about it is embedded onto the platform. And then rendezvous server sole purpose is to link the IoT device to the onboarding server for the final provisioning. So thus we're achieving the late binding provisioning, and we're able to change at the last moment, for example, the configuration that the device will be configuration files that will be put on the device, for example. And yeah, so this is the final look, how the graph should looks like. So the TO0 protocol is onboarding server and rendezvous server talking to each other, syncing up, and rendezvous server gets the information of the onboarding server, so it knows where to forward the device when it connects. TO1 protocol happens when the device boots, for example, and so IoT device asks the rendezvous server for the onboarding server address. And TO2 protocol is the final stage where the onboarding device puts all the configuration into the device and provisions and onboards it. So yeah, as I said, FDO is grandfathered from SDO product, and SDO was developed, as I said, by Intel, and their implementation lives on under the name FDO product. That's under the umbrella of Linux Foundation Edge. And they actually provide to the client implementation and the server side implementation. The client implementation is written in C, and their documentation is kind of I didn't actually quite understand some parts of it. And I wrote to the Slack of Linux Foundation Edge under FDO related channels, but no one responded. But in the documentation, it states that it currently only supports x86 architecture. And it was listed that mostly Ubuntu, Red Hat, and Debian. So no one responded to me. So if there's anyone who has any information about this particular subject, please tell me if I'm wrong, because I didn't find any information about this on the Intel documentation available for the SDO product that FDO project is grandfathered from. And yeah. So yeah, client SDK is written in C, and it's really expanded upon. So there's a lot of features potentially available for it. But yeah, as I said, they state that it doesn't support ARM architecture, so that was a no-go for us. And the the second repository is Java-based server implementation, so the rendezvous and owner onboarding servers. And yeah, it looks promising. It has the potential to maybe suit the Yocto environment better because it's more extensible. But that seemed like a lot of work. So we used another existing implementations. And I'm going to be the next person talking about MetaRust today, not MetaRust. And yeah, it's developed originally by Fedora IoT and still is developed by Fedora IoT, but recently they changed their repository ownership to, I think it's fido-rs. So they changed the name basically, and they responded to me on Matrix, and I got feedback that it was because they wanted it to be more of a community-driven project. So yeah, and it's really modular, which is cool, because all the functionalities inside of it are in the form of crates. Those are not all of them. Those are the major ones that we are interested in. So the FDO client cargo is the one actually that we had to cross-compile within Yocto to the end architecture, and because it's responsible for the client side operations. The other ones can run on the server, so there were no problems with them and running them on the machines. And also, there is the manufacturing server here and manufacturing client. As you can see, I haven't talked about anything similar to this in the previous slides. And those are tools to automate the creation of ownership vouchers at the beginning of the supply chain. So yeah, the manufacturer can automate some of this stuff. So we decided to use this project to implement FDO into one of our projects. Because we thought that should be easy, right? And it kind of was. It wasn't that bad. But yeah, Yocto currently has two layers related to Rust support. So it's MetaRust and MetaRust bin. We tried using MetaRust bin, but it didn't quite work for us. So we opted for MetaRust. But there were some issues with cross compilation. So some of the packages use pkconfig cargo in them. And as you can see, pkg config doesn't really support cross compilation natively. And there were a lot of errors when trying to build this bitbake recipe that we created. We initially used cargo bitbake that automates a lot of the process. So As was said, I think 2 presentations earlier, Rust uses Cargo as its package for its package management. And the FDO client crate that we tried to build has like, I think, 400 cargo dependencies. So Cargo Bitwig allows for automation of this tedious process of adding every file to the src URI variable. And yeah, I think the end recipe for just the dependencies is 700 lines long. So there are a lot of packages, and a lot of them use pkg config in them, and some even don't. So there were a lot of linking problems, especially with OpenSSL, that it's known to have problems with cross-compilation inside of Rust. When I started looking into it, I saw a bunch of posts on Reddit and Stack Overflow mentioning this problem. Yeah, we managed to bypass it by specifying different pkg config variables for the host architecture and the target architecture. So as you can see, the bottom ones are handled by Rust compiler, while the top ones are picked by native Yocto builds. And as I mentioned, some of the crates don't use pkg config to find their dependencies. Cargos are not standardized so much. And yes, for example, this OpenSSL, some dependency crate has hard-coded paths in it, and it doesn't work that well with Yocto. So we used pkg config to fix this. There are patches that help find the proper headers and files inside of the Yocto environment. And yeah, the same happened for can be used, for example, for finding the CLang compiler flags for other crates. As I said, I'm having a problem with viewing my notes, and I think I skimmed over some information that I wanted to convey. So, okay, there's the live demo part that we'll get to soon. And I wanted just to mention that the final recipe for the FDO client, Linux app, Cargo, is available at the FreeMDep Meta FDO repository. And the image I'm about to use is also available on the cloud. And the links are in the presentation, the PDF that are submitted to the Yocto Summit site. And this was all developed for Honeystar branch, because the project was originally developed for Honeystar. So we didn't test it thoroughly on newer branches of newer versions of the Yocto project. But the live demo is done on the Keystone branch. So let's get into that. So okay, I have my Raspberry device present. Is everything working as intended with the screen sharing?
Yep, I can see everything. Looks good.
Okay, that's great. So yeah. Whatever. This is the Raspberry machine, and as you can see, it's currently having. You can't see it yet, but you can see it now. Okay, so it has a systemd service running in the background continuously of the FDO client's Linux app. So it runs periodically and checks if it can connect to the rendezvous server. There's TO1 protocol mentioned somewhere here. Oh, there. Yeah. So I'm gonna start some services for those. I'm gonna start those services. I don't like it that it says that the address is already in use. Okay. I know that someone said in the previous presentation that kudos for doing a live demo. I can see why. Okay, I have no idea how to then do it without resetting my computer, because I have no idea where are those services running currently. So
maybe they're still running from a test you did earlier. Maybe
but I mean for sure it's there. Oh, okay. I'm also in the wrong directory. So, but I don't think that will work anyway, because the ports should be still, yeah. Okay, so they didn't quit properly. I don't know if I'm extremely sorry for this, because I tested it like 3 times to make sure it will work, and yet it failed on me. So really sorry about it, but I'll just talk about how it works in practice. So as you can see, I've been running Fedora machines using this Robux, but because as I said, this project was originally developed by Fedora IoT, and it's still mostly supported for Fedora OS. And it was just easier for me than to try to manage dependencies on Arch Linux. And so this is the structure of my technical demo, let's say, folder. So the actual those YML, whatever. Sorry, I don't know how to pronounce them. Their extension in English contain all the configuration for the different services, and the FDO device onboarding-rs project, device-onboard-rs project uses additional service for its API. So here are there are specified all of the provisioning steps, final provisioning steps. So for example, here there's some instruction to put test txt file in the root data directory at the machine. And yeah, I'm really sorry about the technical demo that I can't show it to you, and there's 5 minutes left, so I don't think we'll be able to do anything about it. So yeah, I think that's all for me, from me. And I'm struggling to, oh, there. So yeah, if anyone wants to, I'm available at this email address, and also that's the company email address